I want to give a European perspective. You know that in Europe the idea or the focus is put on unconventional gas production as well, with a few years delay with respect to North America, but yet not much gas is produced. It's just in the very early phase. And so what we can do are speculations and to compare, to draw our conclusions and just to observe what's going on.
We lost you for a while.
And first of all, I want to point your attention why companies are interested in unconventional gas. It's quite simple,
and
because the conventional gas area is going to end in Europe.
Can you hear me?
Which means domestic production.
Okay.
Then I want to skip over to unconventional gas resources, what's believed
and then we
could
get
be
back
in the
to
ground in Europe,
20 minutes or 25
and to focus
minutes
a bit on a few examples with
you.
some scenario calculations. First of all, as I already said, conventional gas production is in steep decline in Europe. UK 10 years ago was the largest European gas producer. Now its production has declined by almost 70% within 12 years. That's a lot. Here this figure shows not each field, but the sum of all fields which are developed within 1 year. So it's a typical decline pattern which we already know from liquid hydrocarbons. That in the early phase the production can be increased, but as soon as the decline starts from the large fields, then we get more and more into problems. Of course, this is similar to natural gas. The second one is Norway, today still the largest producer and most important producer in Europe. Also here, important fields already exhibit a decline pattern. It's not quite sure whether we already have passed peak production, because last year the production might be reduced for other reasons. But it seems to be that we are very close to peak production, and the group around Shale Bank Söderberg, last year has presented a field-by-field production pattern of Norway, which gives the imagination that within the next 5 years production might peak. Even the third most important producer in Europe, in Netherlands, is in decline. The largest field, Groningen, has peaked more than 10 years ago. And this is an official forecast from the government agencies, and it's expected that even in the Netherlands, gas production will decline substantially. Now let me summarize the present view of conventional gas supply for Europe. The lower part of this figure gives the domestic gas production, which has peaked with UK around 2000 or a bit later. And any authority or any institute involved in such analysis agrees that domestic gas production will decline in the future in Europe. There's a distance how fast it will decline. This is my personal view based on some analysis. On the upper black line shows the expectation of demand development given by the World Energy Outlook from 2008, the next one in 2010, and the latest one in 2011 I didn't include, but it might be a bit slower than 2010. And the hope is that a lot of gas has to be imported and will be imported from new sources outside. It's not my topic where it will come from or if it might come from, but that's the situation in Europe. Conventional gas supply is, domestic gas supply and production is declining steeply, and imports are expected to rise with all the involved consequences of that. Which means the supply risk will rise. It's not a supply risk in terms of availability or security, but also of cost. So there's a rising uncertainty in the system. And that's the reason why companies focus on unconventional gas. It's an attempt to reduce these risks. But, and here I hoped to the input from the United States, the specific production volumes from unconventional sources are much, much smaller than from conventional fields. That's simply because the largest volume is contained from rocks, and only a few small pores are in, and you have to extract the gas out of these pores. So your effort rises, and your effort to extract this gas rises, but at the same time you earn less gas, so your total and your specific effort rise. And this in turn will have the consequence that the production costs will rise considerably. And this is in contradiction what is claimed of publicly by many companies also, that we will have a rush of gas, a new age of gas with cheap gas, and this cannot work together. So said companies focus on unconventional gas is first an indicator that conventional gas era is going to end, and secondly, that they expect that gas prices will rise. Now let's focus. First, I just want to put the focus a little on the different sources of unconventional gas. Most prominent is shale gas, which is the gas remained in the pores of the source rock because the source rock was too dense, it was not permeable, so the gas could not escape when it was produced. The second one is coal bed methane, which is gas absorbed in the coal of in the pores of the coal seams. And the third one is tight gas, which is just gas absorbed in the pores of the rock as well, but the permeability is much higher than from shale gases, but much lower than from conventional gas. These are the basic types of unconventionals we are talking about. The production methods are more or less similar, but the effort differs between the different shales, between different species of unconventional gas, because the porosity differs in these rocks. And the method of choice is so-called hydraulic fracturing, to pressure in under huge pressure water with some additives, with chemical additives, with propans, with sand, to produce cracks underground to freeze the gas. And just to sort it, here is this graph shows the permeability, also how fast the gas comes out of the rock. At the right is a conventional gas field, and some orders of magnitude lower in permeability is tight gas, as a gas in dense rocks, and even 1 to 2 orders of magnitude lower is shale gas, which is almost as impermeable as salt. So it needs a huge effort. This is some years ago by Schlumberger, a map which shows the areas where it is expected that gas shales or tight gas or coal bed methane areas might be. There's in the north, especially in Middle Europe, are huge areas. The blue dark are the shale gas areas, the green ones the tight gas, and the red ones the coal bed methanes. Predominantly it's closely linked to coal deposits. This has been revised for several times. The latest revision was given by the US Energy Information Administration, which last year published a report, World Shale Gas Resources, an initial assessment of 14 regions outside the United States. And one of these 14 regions, of course, was Europe. And here this study concentrated only on shale gas, not on coal bed methane or others, because shale gas is seen to be the most important resource of the future. Here's this Baltic area. I just want to skip that. It was a detail. Just to give you some figures. As I already said, the conventional gas production is in steep decline, but there are still a lot of reserves in Europe. Putting it together, it's about 4,000 to 5,000 billion cubic meters, compared to about 300 to 400 billion cubic meters which are produced each year. And the remaining reserves are concentrated in a few areas, especially in Netherlands and Norway, and a smaller part in Romania. All these three, except of Norway, are already in decline. Now we add the estimates of unconventional gas. I just shaded in because resources are not very ensured in their data quality. Therefore, I put it very cautiously. But nevertheless, it is believed that especially in France, Netherlands, or Poland, but also in Austria, there could be huge resources of natural gas, which eventually could be produced someday. And first of all, that's the difference between resources and reserves. We already have heard it this morning, but to make it more specific, reserves are much more proven or much closer to reality, I would say, to possible production volumes which one day might be produced, while resources always have a very speculative character as well. It might exist, there is no idea whether it can be produced someday, the costs are unclear and so on. So it doesn't matter how much resources we have in Europe, what counts is how fast can we dig it out and at which effort and how large will be its contribution. And here I want to make some scenario calculations. But first of all, again, back to the technology. A major problem which turned out to be serious in the United States is a high drilling density, the density of well pads, which sometimes is 4 to 6 well pads per square kilometer. And companies have learned and they want to drill more wells per well pad. This is a schematic example. In Germany, the companies are talking with 14 wells per pad. In Austria, up to 25 wells per pad. And just to put them horizontally downwards and over a larger area, so that not each square kilometer and one well pad is needed, but maybe one every 10 or 25 square kilometers, just to reduce the environmental impact on the landscape. These are the ideas. I just want to summarize some potential environmental risks which are known from the United States, where we have the only country with a large experience, where we can have large statistics, and we have had problems. Most prominent are air emissions, water contamination, noise emissions, of course, as well, and uncontrolled subsurface diffusion of methane or chemicals. And above surface, it's a huge consumption of landscape for the well pads, for the roads in the countryside, where many trucks must run, and in average about 2,000 to 3,000 trucks per truck movements per well are expected. So, which means if we compare it with the German situation, we are with 14 wells per pad, which means this means about 30,000 truck movements just for one well pad. I don't want to go into details of this overview, which has been published in many places. I just want to focus a bit on differences. And a major difference between the United States and Europe is the population density. Here it's drawn in the inverse population density, which means the area of the land and the inhabitants. And here in the United States, for each inhabitant, we have about 30,000 square meters. If you go to the other end, in Germany or UK, we have about 4,000 to 5,000 square meters, which means there's a factor 10 to 20 more densely populated. And keeping in mind the huge consumption of land area with these well pads, this, of course, has a much faster, brings much earlier the conflicts between the interests of inhabitants and of the oil and gas companies. Now let me just add another number, which means how many wells are producing in each country. In the United States, we have about more than 400,000 gas wells and more than 300,000 oil wells. So together about 700,000 to 800,000 wells. In Austria, it's a factor of 1,000 less. It's about 800, and in Germany about 1,600. So we have much more densely populated in this area, and the land is only a very small portion of the land is used for the oil and gas industry, which means that people are not used to oil and gas industry. The cultivated area is used for different purposes, One of them is, of course, tourism, because some of these shales are in attractive areas, another one are vineyards, for instance. So the conflicts, as I already mentioned, might be visible much faster. Now, just a short, not comprehensive, but just a snapshot. In France, fracking was banned by law last year. In Bulgaria, it was not banned by law; it was by a moratorium, but with an open moratorium without a final date. Poland, in this year, considerably downward revised its resources. Some companies tried various dry holes, and one of the largest and most important one, Exxon, stepped out of Poland, as well as of Hungary. After having drilled a few holes, they just decided it's not our business case for the next years to come. Now, what's going on in Germany? In Germany, fracking has started about 15 years ago, or almost 20 years ago, and not in shale gas. In shale gas, it started about 2 or 3 years ago, but in the largest, and I think the only one, tight gas field in Germany, which I come to it later on again. Then in 2010, new areas were offered for exploration licenses. And just to give you a number, in North Rhine-Westphalia, where conventional production ceased in 2005, about 17,000 square kilometers were offered to companies for licenses, and this is half the area of the whole country. Just to give you an imagination, the Barnett Shale in Texas has also roughly about 15,000 to 16,000 square kilometers, and within almost 10 years, more than 15,000 wells are drilled there. So just compare it with North Rhine-Westphalia, it would require that 10,000 to 15,000 wells are drilled in this area if you want to have similar effects than in Texas. We already from the beginning, there is a strong local opposition just from all villages where it was planned and where the companies required licenses. And even the local policy very soon became unsure what to do. In the beginning, they were happy because shale gas activities or gas activities from the companies, they are a garant for a new income but the more they observed and followed, and the more critical questions they raised, they became very unsure whether it might be a good idea to follow this. And even early this year, we had an election in North Rhine-Westphalia, and this was a politicum as well. And almost any party raised public audiences, public hearings, and the regional politicians more or less are in general against fracking. And this culminated in earlier this year, when at the German government, the environmental minister and the minister for economics, they agreed to ban fracking, at least as long as a great environmental study will be performed. Exxon, one of the leading companies in working on fracking, was also very surprised about this resistance. And in the beginning, I think it was not very clever how they behaved in the discussions with the public audiences and the inhabitants. But then they learned that they need something which is called a neutral dialogue. So they financed a dialogue process where they put in money, but didn't influence the course of the discussions. And there were 8 experts from whole Germany which governed this dialogue. They collected questions from the public, and they ordered studies, detailed studies on mobility of gas in the underground, the risk for fracks, risk for earthquakes, and so on. And in just earlier this month, a final report has been prepared, which is now publicly available. And to make it short, all experts agree about the quality of the risks. There is some risk, but there is a huge dissent about what does it mean. Should we forbid it or should we allow it? And so I decided to say, of course, you should do it, but cautiously. That's the present status on the political moratorium I already mentioned. Now, I want to focus a bit more on Germany. This is an overview about Germany, where the huge gas areas are. In the Niedersachsen is mostly tight gas, which I already mentioned. Then in northern Westphalia and in the middle of Germany, it's shale gas, and in lower parts it's coal bed methane. And in all three areas, companies have their claims and started exploration activities, which now has stopped until this dialogue process was finished, and now it has stopped due to this moratorium. This is a production profile of the only tight gas field. It started in around 1995 with about 17 wells, and over the last 15 years, production volume declined by about 50%. So about more wells are now active than in the beginning. And at present, the average productivity is about 40 million cubic meter per well per year. This is tight gas. And tight gas is quite different to shale gas insofar as the extractable gas volume is much, much larger than for shales. Shales has much lower productivity rates and has even a much steeper decline pattern, which Arthur hopefully will present afterwards. Here's just an overview about a few activities and the places where the wells are. And I just want to follow, maybe again with the risks and the potential risks which were examined in this dialogue process. At the right, you see the production well, and at the left, a re-injection well for wastewater, because during the fracturing process, you pressure in water under high pressure mixed with chemicals, and you get a reflow when you release the pressure, and this reflow water has to be disposed somewhere, and in Germany it's decided to re-inject it in very specific wells. And at each place you have some risks for contaminations, for breaks, for leakages, for blowouts, and so on. And these were studied in this dialogue process. And one result was also that drilling, the companies agreed that they will prevent leakages from the wells, which means they have a threefold casing about the pipes. This is an example. And this is an area which was in these scenarios. It was assumed a company will start to produce the whole field in that area, and how would it look like? And it's just a landscape in northern Westphalia in the so-called Münsterland, which is very touristic, with this agricultural, with many horses, and cycling roads and ways. And these red areas give the villages with a safety belt of 200 meters, and each gray area is a single house which is there. Here was a safety distance of 100 meters assumed. And each dark dot gives a possible production pad with 14 wells each. At the up and to the right are the scale in kilometers, which means in an area of 200 square kilometers, you have about 22 well pads, each with 14 wells per pad. Now, let's assume a production scenario was what would it mean? And if we assume roughly similar production profiles than in the best shales in the United States, which means the initial production rate, also how much gas is produced in the first months, up to 4 million cubic meter is assumed here, and a decline rate with 7% per month. And the cumulative production per well is about 50 million cubic meters per well. I guess it's very optimistic, but nevertheless. And compared to present drilling activity over the last 10 years in average, it was in Germany about 30,000 drilling meters per year. Let's assume we have a similar activity in the next years to follow. This would mean each month to connect, to develop 2.5 wells per month, each with the same production pattern. Then we would end up at a total production after 5 years of about 140 million cubic meter per month. But as soon as we stop to develop new fields, new shales, the production suddenly would decline very steep. Now, if we would continue and instead of 120 new wells, we would develop 250 new wells over 8 years, it wouldn't increase the production anymore, because due to the steep production decline of each individual well. This is a synthetic and idealized profile. In reality, of course, the companies would sort their areas and to develop the most promising prospects first, which means even if you would keep on with the same activity, development activity, the production would decline very fast. What would it mean? This are 240 new wells within 8 years. In total, we have in Germany about 560 gas wells. I just come to that. And just compare it with this general situation in Germany. This is a present gas supply of Germany. The black line gives the consumption. And imports from Russia, Norway, and Netherlands are most prominent. And at the bottom is the production, the domestic production in Germany. It declined by about 30% over the last 10 years. And if we just add these 250 shale gas wells with a cumulative production of 14 billion cubic meter, it would just give such a small, just visible at that scale within the next 5 to 10 years about. And keep in mind, today we have 512, not 60, 512 active gas wells. This would add another 250 gas shales. So the conclusion out of these scenario calculations is we have a huge effort in developing these shales, but it will have a negligible impact on the production patterns. Then, similar in Vienna, in the Vienna Basin, there are also activities which are in the vineyards or around vineyards. Here it's assumed that the rocks above the shale are 5 kilometers in depth, in thickness, so they have to spend much more effort. Also the rising effort with rising drilling depth means more energy to spend for the production. And if we would put a similar scenario, which I guess it's a fastest speed of development possible, this would add a few percent to the gas consumption of Austria. Now let me finally conclude. First, conventional gas production is in steep decline in Europe, and gas companies expect rising gas prices, otherwise they wouldn't start with unconventional. Europe is densely populated, oil and gas drilling activity is very low, and drilling sites are close to or in strong competition with cultivated agricultural areas. Therefore, conflicts and with interests of the rural population are imminent. And assuming that the gas drilling activity is similar or even a bit higher than present,
can you hear me?
The contribution to domestic gas supply will be small. Strong environmental regulations which are expected to happen. They will increase the cost even further, and they will slow down the development speed. This is one aspect. Many people believe, in the United States, shale gas has a huge contribution, but it was only possible at the cost of environmental problems. It had to be very cheap and very fast, and this is of course on the cost of neglecting or ignoring regulations. Therefore, my conclusion, unconventional gas supply in Middle Europe will not solve any problem of future European gas supply. Thank you.